Hey everyone, welcome to today's episode of the Cyberman Show. Today we are going to talk about the basics of security for IS, PAS, and SaaS. And I know I've been talking a lot about cloud security, especially on the IS and the PAS side, but I thought I'll create an episode focused on all the three cloud types and their basics. Now, the scope of this episode will only be on the technology side. I'm not going to talk about governance, risk management, or policy making side. And let's get started. So, before I jump into the security of the cloud, it's important to remind everyone, especially the first time listener and people who are just trying to build their career in cybersecurity and especially on cloud security, there are three main types of cloud services: IaaS, PaaS, and SaaS, which is infrastructure as a service, platform as a service, and software as a service. Okay, IaaS, PaaS, and SaaS. Okay, now the difference in these types of services on a very high level, and I know you can search it up or on Google or other platforms to understand the difference. But however, the major difference is what you can do or manage in these in various types of cloud. So, for example, in SaaS, you're typically using this a cloud hosted application like your emails. Gmail is a common example. In a PaaS, you're creating your own applications, you're managing the data yourself. The other layers like runtime, middleware, operating system, virtualization, servers, storage, networking are all left to the service provider of PaaS to manage. An example would be GitHub. Okay, infrastructure as a service, this is where as a customer of IaaS platform, you're going to manage application, data, runtime, middleware, OS on your own, virtualization, server, storage, networking, all that is managed by the provider. An example of IaaS would be Microsoft Azure, AWS, IBM, Oracle, etc. Okay. Uh, Now, there are large companies like AWS, Microsoft Azure, GCP, Oracle. They provide both IaaS, PaaS. Microsoft, in fact, provides SaaS also in terms of Office 365 and other applications. They have a large enterprise stack. Now, those are the basics. Okay. Now let's talk about the security layers. Right. So there are two types of layers that we can put together in the most simplest fashion. The first one would be the basic security. The second one would be advanced. Basic refers to anything that is provided natively by the cloud provider. So, for example, for a SaaS, it would be any security settings like enabling two-factor or a multi-factor authentication for user, changing password every 60 days to 90 days, or any other thing or any other policy like that that secures the SaaS. Okay, for AWS, IaaS or PaaS, there are multiple native controls. For example, there is Amazon Guard Duty, Secrets Manager, Directory Services, Cognito, VPN, Inspector, WAF, Macy, Security Hub, Shield, Artifact, Organization, Firewall Manager, Detective, Cloud HSM, IAM, etc. Right? There are more services, and most of these service providers are keep launching new services every few months or years. Okay. Now, again, these could be further divided into basic, advanced. Uh, it completely depends on your requirements. The key takeaway from here is that every cloud provider, whether SaaS, IaaS, or PaaS, they come up with basic cybersecurity controls. Now, these controls have to be configured based on the recommendations or best practice frameworks. Example for AWS, there is AWS Foundational Security Best Practice, FSBP standard, as well as third-party recommendations like CIS or Center for Internet Security, AWS Foundation benchmarks. And you will find such best practices and benchmarks from most of the service providers as well as third party. So there is an Azure best practice framework, or there is a reference architecture, and there is a benchmark for Google from CIS, benchmark for Azure also from CIS, and multiple other standards and frameworks are there, right? So the native cloud provider controls have to be configured based on what functionality is provided and align them to a particular standard. Now, not every service which is provided by one cloud provider will be available for other cloud providers. So, example, firewall is a very basic control that everyone provides. So, Azure has a firewall service, AWS has a firewall service, GCP has a firewall service. Uh, but not everyone has a DLP service. Not everybody might have a certificate management service. I'm not saying they don't have. I'm just trying to tell you that whenever you're looking to standardize capabilities, just make sure that whatever cloud provider you are using provides those set of capabilities, and within that service the features might not be the same. So for example, is the firewall layer 7 on all these providers? Maybe not. That is something that you have to investigate, and based on your requirements decide if you want to go with a native control, or you would want to go with a third party control, which is typically part of the advanced security. On that note, let's move into the advanced security side. So these are essentially third party controls. Okay. So if you talk about IaaS and PaaS, um, if you're developing applications uh, on these platforms, typically the role of developer traditionally was always responsible. Developer was traditionally responsible to use security for application-based artifacts like their code, APIs, OSS, or the open source software components, IAC scripts, infrastructure as a code scripts. And they would use third-party products like SaaS DaaS, API security, SCA analysis, IC scanning. They're doing that, right? And when it came to workload, the idea would be to get a cloud workload protection platform, CWPP, and secure those containers, serverless functions, and virtual machines. And when it came to the infrastructure, uh, which is networking, storage, compute, you will typically use CSPM to look at the configuration and suggest remediation and find gaps. And then if you're looking into identity and permissions, you would use SCIM, cloud identity and entitlement management, to look at any issues around identity. Now, since last few years, all these capabilities are offered by a single platform, CNAPP, Cloud Native Application Protection Platform, that provides the full capability for securing entire development and operations of apps on the cloud. Now, I've done multiple episodes on CSPM versus CWPP, CNAPP also. So I would recommend you that if you're hearing these terms for the first time, go ahead and look back into the previous episodes. Okay, so CSPM, CWP, CIM, other cloud-related capabilities are now provided as one platform called CNAPP. Now, CNAPP is all about securing. And I'm just trying to double click this here, is securing the application related artifacts, application development related artifacts, as well as while the application is running. Okay, so it looks into the cloud configuration. This includes things like IC scanning, network security and configuration, uh, cloud infrastructure entitlement management, CSPM, Kubernetes security posture management, data security posture management, etc. Okay, and then on the application side, it would look into traditional SaaS DaaS capability, API scanning, software composition analysis, pipeline posture management, looking at exposure of CV, secrets, sensitive data, malware, unknown vulnerabilities, attack path analysis, etc. And while the application is running, it's going to look into the web application and API protection, application observability, cloud workload visibility, network observability, and any exposure scanning like CVE, secrets, sensitive data, malware, unknown vulnerabilities, as well as attack path analysis. Now, all this data, while it's used in different stages of application rollout or application usage, cloud detection and response technologies consume data from various uh, points or various sources of data and put all that together in case there's an incident on the cloud and somebody needs to investigate. And you'll find some content on CDR also in the previous podcast. Okay, so that was IaaS and PaaS. So typically you would use a third-party platform either a CNAP or specific functionalities like CSPM or CWPP, CM, etc., based on what you're trying to do in your scope of work or a project. Okay. Now let's talk about SaaS. Now, within SaaS security, of course, reminder basic security is with the SaaS provider. So, example, a app like Okta, the Okta as a company will definitely give you certain best practices and recommendation for security. Uh, and then there are third-party platforms like SMP, a SaaS management platform that provide admin, RBAC, policy management, license management, and IT workflow automation capabilities. Then there is, of course, the SaaS security posture management uh, that allow you to control or manage the configuration of your SaaS apps, things like drift control, SaaS to SaaS connection, alignment of these security configurations with best practices, frameworks, UEBA, reporting, etc. And then there is CASB. So CASB is all about controlling who can access the third-party apps. So any shadow IT related use cases, which means essentially using apps that are not approved by the company, data security, threat protection, etc., are covered in CASB. And then there's of course SSE, which is all about uh, access and URL filtering, threat protection, DLP. And some of these use cases are now getting converged. So, for example, the top SaaS SSE providers are now trying to use or build CASB capabilities natively in the SSE platforms, the Secure Services Edge, or the full SASE platform as they are called. Okay, so that was SaaS summary. Uh, SaaS applications come with their native cybersecurity controls, cybersecurity best practices, and then you can use third-party controls like SSPM, CASB, SSE, based on the use case uh, to have advanced security. So that was the summary, or that was the main content for this episode. Now, what I would recommend is, based on the requirements and availability of resources at your end, start learning about them. Maybe you can start with learning about one cloud, understand what native security controls are provided. So, example, start building an app or maybe configure a VM. Look at what controls you need to secure that virtual machine and in what conditions you will need other native controls. So maybe categorize these native security controls into basic and advanced. And then you start applying third party controls if you have access to them. If somebody is giving you a trial, etc., try that. Learn as much as you can. Also, start with understanding uh, compliance of these controls to one best practice framework. Go with native, uh, the cloud provided native, or a third party like CIS, depending on whether you're using SaaS uh, or IS or PAS. And that's it. With that, thank you so much. If you like the content, please share it with your friends and subscribe to the podcast or the content on the YouTube channel. I'll see you next time.